All right, we're going to learn about writing polynomial equations or functions. So number one, the property says if you have a polynomial equation of degree n, then counting multiple roots separately, the equation is going to have n roots. So for example, if you have a third degree polynomial, you'll have 3 roots or zeros. The second property says if you have a complex root, then you'll have another one at its a conjugate because they occur in pairs. And the fundamental theorem of algebra says if a function is a polynomial of degree n, and that degree n is greater than 1, then the equation f of x equals 0 has at least one complex root. The next theorem is called linear factorization theorem. So here is a polynomial equation. You can rewrite it in factored form. This a sub n is your leading coefficient, and then the c sub 1, c sub 2, c sub n are all zeros. And if we expand that out, FOIL it out, we will get a nth degree polynomial. So here's an example number 5. So we have an equation. It's a 4th degree polynomial. We have a 0 at 2, and then we have 2 more zeros that are complex. And it says that there is a repeated root of multiplicity 2. So that means there are 2 of these zeros. So in factored form, here is your first factor, and since it's a repeated, that's your second factor. So it's x minus 2 and x minus 2. The other 2 complex zeros in factored form are x minus the complex number and then x minus the second complex number. And if you were to distribute out all 4 of these parentheses, you would end up with this 4th degree polynomial. So we're going to go ahead and do an example similar to what you might see in your assignment. So we want to find an nth degree polynomial. So the first thing we give you is n equals 4. That is the degree. So we're going to have a 4th degree polynomial, which is a quartic function. Then we give you some zeros. Negative 2 is real, so that's an x-intercept. Positive 2 is real, so that's another x-intercept. And then we give you a complex 0 of I. So that means there's another 0 that is the conjugate of I. So that would be negative I. And then we're going to ignore this last piece of information until later. So we're going to use the linear factorization theorem in this yellow box and write them in factored form. So the linear factorization theorem says f of x equals a sub n, the leading coefficient. Then you go x minus the first 0, x minus the second 0, x minus the third 0, and then x minus the 4th 0. Notice that all of them are always x minus. Now we're going to simplify those minuses into an addition symbol in the first parentheses. The second parenthesis stays the same. The third parenthesis stays the same. And then that turns to a plus I. Now we're going to FOIL these first 2 binomials and then FOIL those next 2 binomials. So here's what we get. We get first x squared outside, negative 2x, inside 2x, last of negative 4. Then we go again and we FOIL. First x squared outside, ix, inside negative ix, and then last negative I squared. When you multiply complex conjugates, so these are complex conjugates, the middles always cancel, so you really don't have to FOIL fully. You could just do first and last because those two middles cancel. All right. Now we're going to combine like terms in the middle, and that positive 2x and negative 2x cancel out. And then we said in the previous step that those ix's cancel out. Remember, an I squared is negative 1. So you have negative 1 times negative is a positive 1. Now we have two binomials that we have to FOIL again. So first is going to give us x to the 4th. Outside is going to give us x squared. Inside will give us negative 4x squared. And then last is negative 4. Combine like terms, which are in the middle. So we have a 4th degree polynomial, but we're missing this leading coefficient, a sub n. So now we're going to work with that f of 3 equals negative 150. So we're going to substitute 3 in for x, and then what that equals is your output of negative 150. So the function, when you evaluate it for negative 3, you're going to get negative 150. Sorry, positive 3 here. Now we're going to simplify that bracket. We get 81, and then 3 squared is 9, times negative 3 is negative 27, and then minus 4. And then we simplify that bracket again, and we get 50. So again, we're trying to find that leading coefficient a sub n. So now we're going to divide both sides by 50. So that leading coefficient is negative 3. So now to finish the problem, we're going to take that negative 3 and substitute it right there for a sub n. So negative 3 is going to replace the a sub n. And then you have x to the 4th minus 3x squared minus 4. Last step is to distribute the negative 3 to all three of those terms. So you get negative 3x to the 4th plus 9x squared plus 12. So here is our 4th degree polynomial function. On the left side of this slide is the function graphed out with the viewing window shown. So here is your quartic function. Here is an x-intercept at -2. Here's another x-intercept at 2. If we look on our graphing calculator and we trace along the curve, right down here, over 3 down -150 would be an ordered pair, a coordinate on that curve.